Yeah, good afternoon.
Good afternoon.
I hope you are all doing well.
Yes,
Okay, we thank God. So today is our first day meeting, and
Yo, sir.
first of all, uh, I will tell you a little bit about myself and also a little bit about the course. So today, we're not all that learning new thing. I have put some learning material there, and there's some technical issue they are solving. So by the close of this weekend, they will solve it. So you see all the learning material on the LMS and you can study it. And I'll also help and do my best to try and do recap, or we'll all go through from week one up to the week three before we proceed ahead. I have shared the course outline, so course rep will also share with you so that you can do private studies by yourself. And if you have any question, I'm always available for you to contact me and we will take it from there. Or if you have any challenge on a certain area, you can contact me privately and we will all go through it once again. Okay, so let me start. My name is Dr. Derrick Antwi, and I work under the Faculty of Forces, that is Computer Science Department, and I teach logic in computer science, introduction to computer science, data structure and algorithm, and also digital computer design as well. So digital computer design is a more of upgrade of introduction to computer system. And if you forgot about your fundamentals or the introduction to computer system, you'll find it difficult moving on or moving ahead of this course. I hope all of you did the introduction to computer system.
yes,
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 so
sir.
it means that I don't have issue with it at all. Okay. And when you talk about digital computer designs, first of all, let's look at the digital. I'll share the screen very soon, so don't worry. First of all, this is just a recap of introduction to computer system. Then you enter in proper into the digital computer design. So first of all, you look at the what is digital. You also look at what is computer, and you also look at what is design. So I'll ask this question, please. How do you understand introduction to computer system? Any of you can talk. How do you understand? It's an open question for all of us. Dave, how do you understand introduction to computer system?
No, please give me some few minutes and let me. I'm buying some. There's a little bit.
Oh, okay. Okay, I think there's noise at your end. Okay. Okay. Please, who again? Please, Raman, how do you understand introduction to computer system?
Hello, Doc.
Hello, Eric.
Yes, Doc.
Please proceed.
I think combining hardware and software to produce an outcome.
Okay. So combination of the hardware and the software. Oh, okay. Thank you, my brother. Theodora, how do you understand introduction to computer system? Yeah, Theodora, we are listening. You can proceed.
Hello, Doc.
Hello, say.
Yeah, so good evening.
Good evening, Justice.
All right. So I want to clarify that I think we didn't do introduction to computer system. We rather did digital electronics as
Oh,
part
okay.
of the course.
Oh, okay.
So that's maybe it could be the issue, but I would like to share my opinion on the
Oh,
introduction to the computer
okay.
system.
Okay.
So for me, I think like my brother indicated, is that the physical parts, which is the hardware or software put together to process take input from user, process information, and also give an output to the user.
Oh, okay. Okay.
Okay.
Okay. Okay. So thank you very much, Justice. Yes, sir, as Justice said, so when you are talking about the introduction to computer system, it's the fundamental of computer. So the fundamental of the computer, computer have the software and the hardware. So I normally give this scenario that software and the hardware, if you're having a two. Okay, so please, sorry, my internet had an issue. So give me a minute, just 1 minute. I will continue.
That you use for us. Tell me what.
Different slides. Where the best like? Hello. Hello.
Hello, sir.
Yes, sorry. Yes, I'm back. Uh, so as I said, yes. When you talk about the introduction to computer system, that is the fundamental of the computer. You're supposed to know the hardware. Also supposed to know the software, and knowing these two, it will help you. Then you're supposed to also know the CPU, and the CPU is the brain of the computer. And this CPU have been divided into three sections. We have the memory section. We also have the control unit, and we also have the logic and the arithmetic part of it. And all of these things comes together to form the computer. And even in the software, we also have a sessions. So the software, we have two sessions of the software, or two types of the software. We have the system software, and we also have the application software. So I always give a scenario that if they had two girlfriends, and one always come to the house and start working without any instruction. Other also came to the same house with a specific instruction. So this give you a specific duties of these types of the software. So always the system software doesn't need permission from you or instruction from you. It does the work by itself, but always the application software need instruction to perform its functions. So all these things comes together to form the introduction to the computer system. We also have the memory speed that's measured by the haze and so on. We also have an optical devices such as pen drive, compact disc, and the DVD. And we also have the uh, external memory as well. But the external memory doesn't fall under the optical disc. So optical disc is the disc that doesn't reach up to 1 terabyte. So that is the brief of introduction to computer system. Then we are come to build upon that. So we are come to look at the digital aspect. We are come to look at the computer itself. Then we also look at the designs. So what are some of the designs? The designs of the CPU, the designs of the bus, the design of the motherboard. We will look at all these things as well. So I want to ask the question, how do you understand the word digital? Digital, digital. Yes, how do you understand the word digital? Aaronata. Yes, Amwakon, please proceed.
Yes, sir. Please, good evening.
Good evening, sir.
Yes, please. Digital, if I hear digital, what comes to my mind is about software or something that I can see but I cannot touch.
Oh, okay, okay, okay,
Hello,
okay.
Doc.
Yes, sir, Justice.
Yeah, so I would like to also try. For digital, I think when we talk about digital, something that is in disparate nature or binary numbers.
Okay, 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 I like it. Binary numbers. Oh, I see. Good. Yes, who again? My ladies, are you there?
Sir Aaron,
Aaron, yeah, proceed.
yes, sir. So, per my little knowledge, I can say is a electronic system that stores and then process information.
Okay, that stores and also process the information. Okay. Yes, anyone else? Okay. The ladies, please, you have to talk. I remember this name. Cynthia. Cynthia, the floor is yours. Proceed. Okay. Okay, last person, then we proceed to the next.
Hello, sir.
Hello,
This
Dennis.
is Dennis. Yeah, I would say it's a binary system that like forms the basis of modern computing or
Oh,
modern
okay.
computer systems.
Oh, okay. 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 It's a binary that form the
Yes.
modern computer system. Yes. Yes. Good. Then we are come to move on to the computer. How do you understand the word computer? Anyone can talk.
Hello, Doc.
Doc,
Hello, say Justice.
otherwise you can go.
Okay. So I think a computer is any electronic device that take input from user and process
Okay.
those inputs
Oh,
at the end of the day, giving an output to the user.
oh, okay.
So they take inputs from user, process it, and send it out to the user as an output. Any electronic device that does that.
Oh, okay. Okay. Thank you very much. Who again?
So, Doc, I also say that it's an electronic device that accepts data as input and process it under instruction.
Oh, okay. Okay. So please, can you tell me types of computer that we have?
Hello, Doc.
Yeah, hello, Justice.
Think
Today it
for
seems Justice is only talking.
okay, so for the type,
Theodora, I want to hear your voice.
okay.
Just you can proceed.
All
Okay.
right, so for the type, I think by size you can look at micro supercomputers and other stuff.
Yes.
Um,
We
The
have the
mainframe
personal
computer.
computers, as you
yes.
said, the micro, the super, they are all there. They are all types of computer. Please, who again? Who can also tell us the meaning of computer? I don't want to start mentioning names. Who can also tell me computer? Benjamin Atta.
Hello, sir.
Hello, yeah.
Mainframe.
Okay. Yes. Mainframe is also a type of computer. Oh, okay. Okay. Thank you very much. Then we come to the last part of the topic for today. Design. 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 David, you can share the screen now for me. Design.
Doc, is the outline.
Yes, please, the slide. I have sent to your WhatsApp. I'll send you through WhatsApp. I want to try it here, but I'm finding challenge small.
Okay, sure. Okay.
So whilst you're waiting for David, this is the last part of the topic is design. How do you understand it? And it's a Japan. How do you understand design?
Sir,
Hello, Christopher.
yeah, I would say it's a process of creating and organizing elements in a software, hardware, or digital system to make it functional or user friendly.
Oh, okay. Oh, okay. Good one. Thank you.
Hello, Doc.
Bright? Yeah, hello, Justice.
All right, so can we also say that designs are process of creating circuit and system using binary data?
Yes, yes, you can also say it that way. Who again? Last person. Please, if you are not on the floor, you mute yourself. Benjamin, are you on the floor?
Hello.
Good. Hello, yeah, Benjamin.
I'm having network, so I don't know if you can ask your question again.
Oh, okay.
Hello.
Hello, Ben.
Yes, sir.
You said something. I didn't hear you clear.
I'm having issues with my network, so I don't know if you can ask your question again.
Oh, okay. How do you understand design?
Design.
Yes.
Simply means the act of planning and creating something with intentions to solve problem.
Okay, it's the art of. I like it. Okay. Yeah. So then, who will tell us the full meaning of digital computer design? Now, we have discussed about the meaning of digital. We have also talked about computer, and we have also talked about design. So let's put it together and frame one definition. Who who will talk? Yes, who is on the floor? Who is on the floor?
Hello, Doc.
Hello, sir.
So I would say digital computer design is a study of principle and techniques used to design and build digital computer system using binary logic and digital
Okay.
electronic circuits.
Oh, okay. Oh, okay. Okay. Who again? Last person, then last person, last person. Ebenezer Kabute, please. You can also contribute. We are listening.
Hello. Yes,
Hello, yes,
so
sir.
I can say digital computer design is the process of designing the hardware, the software, and then the logic, the circuit in a way to process information.
Okay. Okay. So all that you have said is true. You have talked about the definitions and the idea of the topic, what you're coming to do for today. And it's true. So when you talk about the digital computer designs, we are talking about the principles of designing a component of a computer to solve a problem. That's why I do recap about the introduction to computer system, and it mainly also talks about how the computer functions and when error happens, what is the way for us to solve those problems. And they are all good. So David, next slide. So we will talk about the introduction to binary system. Introduction to binary system. Introduction to binary system. So let's look at the binary. So what is binary? What is binary? And we also look at the system. Yes, class, what is binary? Yes, sir. Amakon, please proceed.
Yes, sir. Binaries is zeros and ones.
It's a zeros and ones. Okay. Okay. What about system? System. Yes, anyone? system, you normally see that, hey, yesterday, Spain team were having a strategic system to win the game. So when you talk about system, what comes into the mind?
Hello, dog.
Hello, say.
Yeah, so can I say it's a component that work together to achieve a common objective or
Yes,
perform a specific task?
yes, yes. So today we are come to look at the introduction of the zeros and the ones, how to work together with the component to achieve a specific goal. And these zeros and ones is the binary system. Okay. The binary system is a way of presenting data using zeros and ones. This system is used by computers to represent all the data it works with. The binary system is a way of representing a data using zeros and ones. This system is used by computers to represent all the data it works with. So when we talk about the binary system, we talk about the zeros and ones. And these zeros and ones represent a computer data it work with. And can we give some of the examples of the data the computer work with? Can we give examples? Any example of computer data?
We say
Yes, sir.
numbers.
Numbers. What again? Yes, who again?
Lines, test,
Please. He said, come again.
test.
Test. Yes, what again? Emmanuel. Symbols. Please, what again? We have talked about numbers, we have talked about text, we have talked about symbols. What again?
Characters.
Yes, characters. Yes, please can proceed. Yes.
Video or audio.
Please, you said?
Video and audio.
Yes, that's the multimedia, videos and audios. So this our computer represent by these data. And our data are text, either images, symbols, our videos, our audios, and characters as well. So down there, you see some numbers there. You have 101110001111111111. These are some of the data. So sometimes too, when we check our memory, you see our memory data is represented by the number of either the kilobyte or megabyte or gigabyte or terabyte. And all these bytes, the data is being represented by what? These numbers. Sometimes not only numbers, it's also represented by what? Names. That is text. You will see a text. Sometimes when you check on the memory, it's represented by, or when you check on the computer, it's represented by what? Images. So when you see these images, you know that, okay, for instance, when you visit YouTube, you want to download a music, when you click, if you need Shatawale music, you go and look for Shatawale videos or image. So when you see Shatawale image there or name there, then it means that you're looking for Shatawale. When you come to our school system, index number represented by us. So when I'm looking for David, I will just look for David index number or David name, or I will look for David phone contact. So the contact and the index number, they are all represented by what? Numbers. If it is David name, it's also being represented by what? Text. And sometimes to some even go extend that they use images. So when you see the image there, it's represented by David. So when you see David image, that means it's for David. When you see Theodora image, it means that it's for Theodora. When you see my image, it means that it's for me. And everything that attributes will direct to myself or either David or Theodora. Next slide. You also look at decimal system. Decimal system. Decimal system. The number system you use in everyday life is called decimal system. Let me repeat again. The number system we used in everyday life is called decimal system, where we use the number 1, 2, 3, 4, 5, 6, 7, 8, 9 to represent all of our numbers. In this system, each digit is a power of 10. Each digit is a power of 10. Each digit is a power of 10. So you're saying that all the numbers that we use in our daily life is called what? A decimal system. And it starts from the 1 up to what? 9. And from 9 going, you see it repeats itself again. So you tell us that each digit represents what? A power of 10. So who can tell us a power of 10? A power of 10. Who can tell us? When you say a power of 10. Yes, anybody? When you say a power of 10, can someone explain to us?
Sir, please, is it 10 exponent 10?
Yes. Yes.
Okay.
Yes. Yes. Okay, let's move on into the next. Yeah, so this slide, you see that we have a digit value. We have 7, we have 4, we have 3, and we have 10 exponent of 3. We also have 10, 2, we have 10, 1, we have 10, 0. We also have, so the 10, 0 is what? 10 is equal to 1. We also have 10, 2 is also equal to what? 100. We also have 10, 3. It's also what? It's equal to 1,000. Let's move on to the next slide. To compute a number in the system, you would multiply the digit value by the place value. Then add them all together. So to represent the number 4379, you would have to compute. So he gave us the 4379. So you need to compute. So how do you compute? Always, when you start from the back start from what? The ones. We have the tens, we have the thousands, we have the, so it move on like that. The hundreds, thousands, and so on. It move like that. So this one, he solved the sequence for us. So when you start from the back, it will be 9 times what? 1. When you start from the next one, it will be what? 9, 10. When you start from the 3, number 3, it will be what? 900. When you start from the 4, it will be what? 4,000. So when we even bring in our daily finances or money, you see that wherever that you see 4 digits, it means that it's in thousands. So when you see the 3 digit, it means that it's in what? In 100. When you see the 2 digit, it means what? It is in tens. And when you see 1 digit, it means that it is what? In ones. So he's telling us that to compute in this system, you would multiply the digit value by the place what? Value. So the digit value is the normal value, and the place value start from what? The ones, the zeros, the ones, the tens, the hundred, the thousands, and so on. Okay. So Dave, go back. Go back. Yes. Go back. Okay. Then Dave, I'm also come to give my raw figure. You can write it somewhere. Then you also tell me, you also compute the number for me. So if you are ready, you can also write the number somewhere. So you can put your jotter somewhere, or you can use your other device to capture the digit. I'm also giving you 4 digits. You compute and you also tell me what you get for me as well. 7,439. 7,439. Compute from a digit value to a place value for me. 7,439. 7,439. So you compute from a digit value to a place value for me. So when you're done with solving, then you can tell me the answer. Then I need 2 or 3 people to give me the answer. Then we proceed to the next level. Please, I hope you have get the digit.
Yes, please.
Okay. Prince Afu, are you done?
No, Doc.
Okay. Please, let's speed up.
Hello, Doc.
Yes, sir.
So I would like to try.
Okay. I don't like the word try.
Okay, I would like to give in my best.
Yes, I like
Hello?
that one.
Yeah,
Okay.
so it will be 7 times 1,000
Okay.
plus 4 times 100
Okay.
plus 3 times 10
Okay.
plus 9 times 1.
Okay.
So
Yes.
the total will be 7,439.
Oh, yes. 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 That is it. So this is how the binary help our data to perform or being seen on our devices. So when you see your devices, for instance, your memory have downloaded something, you see maybe 1,000 kilobytes, or you see something like 500 kilobytes. So it has been passed through the binary system so, of the computer. And we already know that the computer memory have divided into what? 3 sections. So who will remember the first section? The first section is what? Who remember that? The first section.
Control units.
Yes, control unit. The second section.
Yeah, we arithmetic logic units.
Yes. And the third section.
The memory.
Registers.
Yes, the registers or the memory. Are you getting it? Yes. So you always that function, the arithmetic function, is the calculation part of it. It's the binary part of it, helping the computer to function very well. Please, are you getting it? Good. So who also, or we all get the same answer? Did you all get the same answer?
Yes, sir.
Yes,
Okay.
sir.
Okay. So let's try the next one. This one, my ladies will talk. Okay. So please, let's try the next one. Okay. 3,794. 3,794. 3,794.
Yes, sir.
I hope you have get it.
Yes, sir.
Okay. Let's work it fast and tell me the answer. My ladies, please do well and tell me
Can I?
something.
Oh, sir.
Yes, sir.
It
Can I
will
say
be
it?
Yes.
3 times 1,000
Mm-hmm.
plus 7 times 100
Mm-hmm.
plus 9 times 10
Mm-hmm.
plus 4 times 1.
Yes. Yes. The same thing. So that is your place value. So you move from the data value to the place value.
Right.
Good. Okay. Then let's move on to the next slide. Good. Okay. So here too, the same thing. The same thing. So they have the 2 and the 6, and so they have the other end is the digital value. That is 2 raised the power 2 exponential is equal to 128. Then you come to the place value. So when you come to the place value, that's where you're coming to use it. You're coming to use the formula. So you start from the ones, the tens, the 100. If it is more than 4 digits, you keep on counting. If it is 3 digits, you know how to do the calculation as well. Let's move on to the slide number 7. To compute a number in this system, you would multiply the digit value by the place value. then add them all together. So to translate the binary number 1001, that is 1001, you would have to compute. So this time around, you say that you times them. You times or you multiply the digit value to what? The placed value. So the digit value is the first number times the place value. So the place value is the ones, the tens, and so on. So this time around, he gave us 1001. 1001. And they times the 1 times 8. Then 1 times 8. Down there, you write is equal to 8. Plus 0 times 4, you write there. Plus 0 times 2, you write the digit there. Plus 1 times 1. What you get, you write it there. Then you add all together to get your answer. Please, are you getting it? Are you getting the picture?
Yes, sir.
Okay, so let's use our previous digit. Our previous digit. So the one that we used, yes, the one that we used, 3,479. We should use it in that formula. Then let's try and see the answer that you get. So please, when you are done, then you tell us your answer.
Hello, sir.
Hello.
Hello, sir.
Hello. Yes, sir.
Please, sir, I have a question.
Okay.
Why this one it is multiplying by the first digit is multiplying by 8,
Yes.
but it is saying that it should be multiplied by the place value, and the place value I think is 1,000.
Yes.
So I think it's supposed to be multiplied by 1,000, but here it is multiplying by 8. And
Yes. Here they gave us the number, but the other one they doesn't give us those numbers. That's why it's being. That's the reason why.
Hello, Doc.
look, I
Hello.
think
Oh yes, I get your question.
the
Yes,
first
yes, yes,
was
yes. I got your question. I got your question. Yes, it's supposed to multiply by the 1,000. Yes, yes. Here, but they didn't multiply. Yes, yes. I got it. So that's why I said we should use the old digit and do the calculation, and let's see. So have you done it?
so please, sir.
Yeah.
Yes, I've done it, and I think this one was multiplying by a power of 2. That
Yes,
is why you got this. So the
yes,
first digit was 2 times 2 power 0.
yes.
Power 0 will give us 1. So 1 times 1 will give us 1. Then the same 0 times 2. 2 was 2, 1. Power 1 will give us 2.
Yes.
2 times what we have here. Then the next one will power 2. And 2 power 2 will give 4.
Yes.
4 times 4.
4.
Then
Yes.
the next one was 2 power 3. And
3.
2 power
Yes.
1 times 8. And the first one was multiplying by a power of multiplying by a power of 2.
Mm-hmm.
This is why we've written this
Yeah.
here.
Yes, I got it. Someone raised his hands up.
Yes, Doc. Please, it's me, Ebenezer.
Okay. Abdul.
Yes, I'm a bit confused because with this question, with what is displaying right now, this is converting binary to binary. So all what we are doing right now is converting binary to binary and converting binary to binary. Is that what we are doing, or is there something different from that?
Yes. So there are two different scenarios. The first one is different, and this one is also different.
So with what
So
is
they are two
displaying
different.
right
They are
now,
they are
it
two
is not
different. Yes.
converting binary to binary.
No. So they are two different. So let's use the first one. The first scenario that I gave. We should use the first one to translate. And let's see the figure, the place value figure that we get.
Okay.
Okay.
So, no,
Yeah, hello.
yeah, so I had 74.
Okay. So you can proceed.
It's 3 times 8
Mm-hmm.
plus 7 times 4 plus
Mm-hmm.
9 times 2 plus
Mm-hmm.
4 times 1.
Mm-hmm. So
Then
that's the final answer.
74.
Oh, okay. Oh, okay. 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 So that is for you, David, right?
Yes, please.
Okay. Has anybody also finished? Okay, so let's wait for maybe two other
Yes, sir.
people. Yes, sir.
Please, to clarify, you mean we are to compute the 1001
No,
with
we are talking about the
place value
previous.
as we did before?
Yes.
Okay.
Hello, sir.
Hello.
Hey there. I'm following
Yes,
your
sir.
class discussion on binary to decimal.
Please, you said?
Sir, please, the number again, because it's like I'm a bit confused about which number we are converting.
We are using the previous one. So, David, can you help them with the number? You can write it at the chat box for them.
So please, can we continue? Or if maybe you can assist us.
Okay, so I'll give only just 1 minute for two people to also present their way. Then we move on to the next step.
Hello, dog.
Hello, sir.
Yeah, so I think I got the same thing that David had.
Uh-huh.
So 3 times 2 exponent 3 plus into bracket 7 times 2 exponent 2
Mm-hmm.
plus 9 times 2 exponent 1 plus
Mm-hmm.
4 times 2 exponent 0. So when
Mm-hmm.
you do the mathematics, you are going to get the 74 base 10.
Oh, okay. Okay. Then it means that you have get it. So then we will proceed to the next. We will proceed to the next. So let's proceed to the next. I'll give multiple scenarios and also an exercise and assignment as well. So uh, let's move on to the next. Okay. So David, move on. We have already discussed this, so move on. Okay. So when we see this one too, it's talking about if the decimal value is odd, then the first digit must be a 1. So it's talking about if the decimal value is odd. So how can you identify that the decimal value is odd? And we know that decimal is our daily life numbers. And we talk of number from 1 up to what? 9. That is our decimal numbers. It said that if the decimal value is odd, and we all know odd numbers. Or who can tell me odd number? Anyone? Who tell me an odd number? Who tell
Hello,
me
dog.
odd number? Yes, sir.
Yeah, so it's any integer that cannot be evenly divisible by 2.
Oh, okay.
In
Okay.
other words, you get a reminder.
A reminder. Yes. Okay.
Remainder.
Okay. Okay. That's great. That's great. So binary practice here, he said that if the decimal value is odd, then the first digit must be 1. So they give us some number. They give us number. So for instance, we have 64. Is the first number odd or an even number? You clearly see that both numbers are odd. Even the both numbers are even number. Then let's move on. So when we move on to 32, I hope the first number is an odd number. So you say that then the first digit must be what? 1. So when you see that we have 32 here, so it means that then we need to bring 1. So it will be what? 132. Please, are you getting it?
Right. No, sir.
Please, are you getting it?
No,
No,
sir.
sir, come again.
No,
Okay,
please.
so this time around, they will give us a digit. So when they give you a digit, the law says that if the first value is odd number, then first digit must be what? 1. So it means that we must add 1 to the first digit. Are we getting it?
Hello, dog.
Okay, so let's use this
Hello,
number.
dog. Dog.
Hello, sir.
Yeah, so I would like to know when you say first value, are we moving from the left to the right or the right to the left?
Oh, from the left to the right. From
Okay.
me, where I'm sitting, from the left to the right. I don't know how you are
Yes.
positioning yourself.
All right, so using the number 64, which
Yes.
one is yes?
So 6. 6 is the first number.
Okay,
Uh-huh.
that's fine.
6 is the first number. Yes. 6 is the first number. So he's telling us that if it is odd, it means that you need to what? Add 1. So the first digit must what? Be 1. So it will not be 64. It will be what? 164. Please, are you getting it?
No, we are not that okay, but I think maybe we'd have to do some examples to understand it better.
Oh,
Hello,
okay.
sir.
Okay, definitely. We will write a example. We will write examples to understand it better. Okay, so let's use
Hello,
this
sir.
digit. Hello.
Yeah, please, a question. When you say
Uh-huh.
if the decimal value is odd, are we looking at both digits of the number, or are we looking at only the first digit?
We are looking at only the first digit.
So if the first digit is odd, then you put 1 in front of.
Yes. So that is the principle of the decimal value of this binary practice.
Okay. So then the 64, the first digit can't be 1 because
Yes.
the
It will be yes. So when you use the 64, the 6 is not an odd number. Are you getting it?
Yes, sir.
So that's why the law must apply. It's not an odd number. So you skip from that one. You will leave it just like that. Then we move on to the next one. That is 32. Okay, so then we can say that 3 is an odd number. I hope you are getting it. Then the law must apply. So after arriving at our answer, when we did the sum up or our calculations, then we come and look at the answer. If the first digit begins with what? Odd number, then it means that we must what? Add 1. If it doesn't begin with an odd number and is an even number, then we should leave the answer like that. So it means that the answer is right. Please, are we getting it? You will try one example, then you will see, maybe you'll get more clarification as well. Okay. So please, let's try this number. I'll write it at the chat box so that everybody will see. Uh, okay, let's try this number. 1482. 1482. 1482. Please, we should use just 3 minutes to solve it. Then I will give an exercise. I'll give an exercise and assignment as well. 1482. 1482.
Doc. Hello, Doc.
Are you done?
No, please. I wanted to ask a question.
Okay, David.
This is even justice. The
Okay,
number that,
justice.
yes, please. So the number that you gave us, so I'm a bit confused as to is it a conversion that we are just applying the law that you just introduced to us?
We are doing a conversion. After the conversion, then we apply the law.
So the conversion, are we converting from that decimal value to the binary?
Yes, please.
Okay, so basically we are converting the decimal value to binary, right?
Yes, please.
Oh, okay.
So then after that, we will apply the law.
You all right? Let me try and get back.
Okay.
Hello, Doc.
Hello, sir.
Yeah, so after my conversion, I had 34.
Okay.
So if you are supposed to apply the law, then the first number, which is 3, is odd. So we put 1 in front of the 3. So you get
Yes.
134, if I'm
Yes.
right.
Yes. 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 So that's what the law says. Yes.
Okay.
Any other person? Okay. Let's wait for few two people and let's see.
Hello, Doc.
Hello, sir.
Yes, sir. So for me, with the conversion, I had 42.
Okay.
But since it is not an odd number, I don't know. Are we to
Yeah,
maintain it
you
like
will not
that?
apply. Yes, you will not apply. We apply only for odd numbers.
Okay, so my next question has to do with, are we considering the whole number or just the first digit from the left?
It starts from the first digit from the left.
Okay, so it's not the whole number, like the
No,
42 or the
no.
42.
Yes, it's not the whole number. Yes.
The first digit from the left.
Yes. Yes, please.
Okay, so I had 42, like I indicated.
Yes. So you will not apply the law.
Hello, Doc.
Hello, David.
Doc, sorry, this is Aaron.
Aaron.
So, I have one humble request, but I think someone's also writing it in the chat box.
Do you know the problem?
Yeah, so,
Maths, you don't do
mhm,
maths on digital. Are you getting it?
okay,
So what I will do for you guys is, although I will give you test and assignment, but yes, though, maybe this evening or tomorrow, I will do a practical session of it for the calculation. Then I will put it on the platform. I hope you have a WhatsApp platform, but I'll send it to Dave. Then Dave will give you, put it on the platform. It's a more of tutorial. Then you follow the steps. When you're
yes,
having any challenge, you can get my number from the rep. Then you contact me.
yes, please. Thank you, Doc.
So I will do that one to help
Okay, sir.
because we don't solve math on online. Yes,
Mm.
yes. So
But
that's
here's
why
the case, we are learning it here online.
here online. Yes. So you need to find a way out.
Okay, sir. Thank you.
Okay. You're welcome. Dave.
Doc.
Yes. So Dave, I want to give a short exercise. Then we'll try our hands on it. And I'll also give assignment as well. And that one you'll try it later within the week or within tomorrow or Monday. Then I will also do a short tutorials for them so that they will follow the principle from one first step to the last step, and it will help. So if I forgot about it, please remind me this evening.
Okay,
Okay.
sir.
Okay. But for the exercise, please, are you all ready?
Hello, sir. Yes, hello, sir.
Yes, sir.
Yes, so sorry about bombarding with you with a lot of questions, but I think
No, it's part of the class. So
all right. So what I am finding it's difficult to understand is, we have done three things so far. The one with the
yes,
placeholders,
yes,
which is base 10 powers of 10, right? Then
yes,
we move on to the binary section, whereby
yes,
we are converting the number to its corresponding binary digit, or is it the digital
yes, yes,
decimal value. But
yes.
in this case, the binary practice that we are looking at, what are we exactly looking at? I am just a bit confused over there.
So
So
what you're looking at
what
it is a
uh-huh.
principle. They are telling us a principle that after or for us to identify a number, we must apply this principle. And the
So,
principle says that the decimal value is odd. If the decimal value is odd, then the first digit must be 1. So that is the principle. So that one is depending on how the question will be framed off. But
okay, so
I just want us to get the concept. That's why I said that after solving your sequence or after solving your math, your equation, then let's try and see if you can find those digits as a odd number or an even number. That is,
okay.
uh-huh.
Okay, so like per what you are saying, it means that when we are done with the conversion,
Yes,
we are to indicate whether the number is odd or the other way around, right?
Yes, please.
Based on
That is
that,
it.
we apply the binary practice rule.
Yes,
First rule.
yes. We apply the binary practice rule.
Okay. All right. Thank you.
You're welcome, sir. Please, if you are ready, then let's write it somewhere. Okay. So exercise question 1. I'll share my email with you. So when you finish, you'll send me the way through my mail. Okay. First one. The first one is an exercise. Exercise. So question 1. To compute a number in this system. To compute a number in this system, you would multiply the digit value. You would multiply the digit value by the place value. Then add them all together. I'm repeating it again. To compute a number in this system, you would multiply the digit value by the place value, then add them all together. So to translate the binary. So I'm coming to mention the digit. 4289. That's the first binary. 4289. The second binary. 1600. 1600. Second binary. Third binary. 1482. 1482. Third binary. Fourth binary. 5293. 5293. Please, we should solve this as an exercise. I will share the assignment to you later on. So those who didn't get it, I want to repeat it again.
Are you taking this from us now?
Okay, do it later on and send to my email. Do it later on and send to my email. Please, I hope you all get it.
Please come again with a question. Come again,
Okay.
please.
So question 1, to compute a number in this system, you would multiply the digit value. To compute a number in this system, you would multiply the digit value by the place value, then add them all together by the place value, then add them all together. So to translate the binary, 4289. 4289. Second binary, 1600. 1600. Third binary, 1482. 1482. And the fourth binary, 5293. 5293. Yeah, the third binary, 1482. 1482. And the fourth binary, 5293. 5293. Yes, 5293. That is the last binary. 5293. And the second binary is 1600. 1600. And the first binary, 4289. 4289.
Hello, Doc.
Yes, sir.
All right.
Please.
So,
Justice, sorry I'm interrupting. Please, I wish that you would share the assignment with us on the LMS, and then you give us a timeline so that when we are done, we upload it on the LMS.
Yes, I will do so, but they are working. They have challenge with I have a challenge with them, so they are working on them. So do this one and send to my mail. The next one that you try, then you put it on the LMS.
Okay, please can we share it with a rep?
Oh
so
yeah,
that
I'll share my mail with
follow?
your course rep. Yes.
No, I'm saying that can we, when we are done with the assignments, can we compile all to our rep so that he send them one to you via mail, or we should do it individually?
Oh, okay. Then you can also do it that
Yeah.
way. So,
Thank you.
Hello, sir.
hello.
Yeah, so I wanted to ask a question, but I was interrupted by my sister.
Oh, no problem.
Anyways, so I want to find out. We are dealing with binary numbers, but the numbers that you give us are in decimal. So I don't know. Is it a different binary system that we are working on? 4 to
They
8.
have decimal number.
Okay. So per what you gave us, he said convert compute a number to in this system, you will multiply the digit value by the place value. So to translate the binary numbers. So when you indicated that the binary numbers. So when you gave this numbers as well, I don't know. Are
It's
these
a
numbers
play.
binary?
No, it's a
Okay.
digit value. It's a place value. Sorry, it's a digit value.
Okay.
As we
So
did as the first one. Yes.
so should we change the binary to place value?
Yes, please.
Oh, okay.
Sir, please, I would like to ask a follow-up question. Those numbers you've mentioned, are they binary or they are in decimal?
They are not in decimal. They are in binary.
I thought binaries deals with zeros and ones.
They are binary numbers, but they are in the digit form. Please, are you getting it?
For me, I'm confused
Yeah,
about that.
I'm confused. I'm confused a bit.
I wasn't confused.
So you are not getting it.
Okay, then let me change it for you. So use the second and the third. Are you getting it?
So please wait second and third.
The numbers. The
One
binary
four
numbers. Yes,
one
yes,
482 and then
yes,
5293.
yes.
So I think we are to convert from the decimal to binary per the number given. We are to convert from decimal to binary. Then we check, then we apply the binary practice. Per my understanding.
No. Let me get back to you. Okay. Then I'll change the first and the last for you. So you maintain the first, second, you maintain the two, the middle two, the second and the third. So I will mention the digits again. So the first digit binary is 1002. That's the first. The second one, you maintain the 1600. The third one is 1482. The fifth one is 0110. Did you get it, or I should repeat it again?
Please, can you repeat
Come
again?
again.
So first is 1002. Second is 1600. 1482 and 0110. So Aaron, the first is 1002, 1600, 1482, 0110. Yes, I think AM have get it. That is Aaron. Yeah, Aaron, you have get it. Yes, Aaron, you have get it. So the question, I'll repeat it for the last time. To compute a number in this system, you would multiply the digit value by the place value, then add them all together. So to translate the binary, that is 1002, 1600, 1482, 0110. Did you get it? As I
Yes,
said,
Lord,
I
I'll
will
get
do
it.
the tutorials and send it to course rep, and the course rep will send it to you as well. And for this exercise, please share with me through the mail. And as you have said, you can compile all of them and send to course rep, and he will send to my email as once. Then next week we will try using the LMS for our studies as well. And you see all the other learning material suggested to you as well. Thank you.
You're welcome, sir.
Okay, so David, we should do it in that way.
Hello,
Today I was
hello,
having a lot
Doc.
of challenge with the LMS and
Hello,
other
Doc.
network. Yes, sir.
Yeah, the previous question you gave, I think justice provide an answer of 42, and someone also provide another answer of 34. I don't know if you justify which the answer is correct.
So which number? The numbers, I should repeat all of them again.
No, I mean the exercise you gave before, the one justice gave an answer of 42.
I don't get it. Justice gave an answer of 42.
Yes, and someone also gave an answer of 34.
They are try work.
Yes.
Oh, yes, yes. They gave two different numbers. So because of it is online, they couldn't show the screen so that we all go through together. Mhm.
Sir,
So that
please,
I'm saying that.
can I ask a question, please?
Okay.
So please, today's target is how to the formula how to convert binary to decimal or decimal to
Yes.
binary.
Yes. Yes.
Binary to decimal.
Yes. Binary to decimal.
So we are to follow your procedure when doing the exercise,
Yes, please.
or we can find our own ways around it.
Let's use the similar one. If you have other method, you can use it as well.
All right, thank you.
You're welcome. So David, as I said, from next week go, you use the LMS for our assignment and even the slides and other things. You'll find it on the LMS. Today I was having a challenge with it. So God willing, next week you will do that. But this week, please try and abide the simple rule for me. Thank you. So David, in case of anything, we will communicate.
Okay, sure.
Bye bye.
Please, David. Hello.
Yeah, hello.
Yeah, please, can you pass through all the slides one by one so that we capture them?
I've shared it on the platform.
Oh, okay. Bye. Okay.
David. David. Hello, David. Hello, David.
David left.
Oh, he left. Okay, I'll send him our private mail. Thank you.